Okay, so we'll be looking at introduction to the OSI model. Please, I won't go through everything. You read some of them. I'll just want to go straight to the point. So we'll be looking at the OSI model, the layers, then what we call the TCP. We'll see the meaning as we proceed, and also the layers of TCP and IP addressing. What do we call, or what do we know as the OSI model? It is simply a theoretical model. It's called Open Systems Interconnect. What just happened here is that those that were well learned, maybe they started with this internet, they decided to divide our mode of communication into several layers or model based on the activities that occur. So they are to start from our physical hardware devices and how information flow from these physical devices down to when the effect has been taken up. That is what is called OSI model, Open Systems Interconnect. It is just a model and a standard for networking and for operations involved in networking functions. And they just did it to address the problems of increasing network size and building stable networks and so on and so forth. What are the 7 layers? We have layer 1 to 7. Starting from layer 1. Layer 1 has to do with the physical layers. That is, physical layers have to do with what you see. The beginning point of network. Probably your mobile phones. Your mobile phones, the network cables, which we also call the category 6 or Cat 6 cable. Please, at this time, you should be calling it Cat 6 cable, not category 6. Some of you want to call it TS something cable. For now, you can be calling it Cat 6 cable. We have gone past that beginner level now. So we call it Cat 6 cable with your RJ45. So all this make up what we call the physical layer. From the physical layer, we now move on to the data layer. From when you plug this to your system, data begin to flow. From the data layer to the network layer to the transport layer, that also denotes how information is flowing, to the session layer. The session layer, when a communication takes place, that has to do with the communication and the activities that happen. The layer 6 presentation layer and the layer 7 application layer. Layer 7 is basically where the software developers are. I think we have software developers here in this class. Yeah. So layer 7 is where they operate, because layer 7 now has to do with the applications that enable us to use all these physical layers. Maybe the operating system of our computer, the operating system of the router. So that makes us the layer 1 to 7 of the OSI layer. This is the short form for remembering it. Please do not throw sausage pizza away, or from up to down. All people seem to need data processing. You can always get your own mnemonics for remembering this layer, because it is very, very important. We may decide to ask an MCQ, and we can decide to ask you to select the correct layers for the OSI. We can decide to put IP in between, or we can put MAC addressing in between, or we can put something convincing in between these 7. So if you don't know these 7 layers, you may fail that particular question. Let's proceed. What is involved in the OSI layer? What is involved in the OSI layer? Like I was explaining, the OSI layer was simply developed to tell us what happens when an information is being passed from maybe your mobile phone to the next person. Now, simply understanding what happens when I send a WhatsApp message to the course rep. It begins with my physical layer, which is my mobile phone, and it ends with her. The application layer has to do with the WhatsApp. All those other information, data, transport, MTN, like we explained, MTN, Airtel, and all of that, is the same thing that happens here. Someone sending a letter, writes the letter, put it in an envelope, just in a mailbox. That letter is now carried to the post office, and is carried by the carrier to the post office. Is now carried from the source to the destination, up to the point when it is now picked and read by the final recipient of the WhatsApp message. So this entire process of sending the WhatsApp or physical letter is the same thing that happens on the OSI model, which is this. From when my mobile phone writes that, it gets transported to my data. Maybe if I have network, it leaves that place, and this transport now happens from Port Harcourt, like I explained in the other class, all the way to maybe UK where she's residing. An handshake occurs. It is now presented to the person to read it, and only when she puts on her data, she can now see the letter. And when she replies, the cycle continues, and that is just has to do with what we call the OSI layer. This is another representation of the OSI layer, starting from the application to the presentation. You see it here. You can see the equipment that are involved in those communication. For the physical layer, we have what is called our switch and our repeaters. Repeaters, we told you, access points can act as repeaters because it simply acts as an amplifier of whatever information is being sent. The data layer, the switch. Hope I don't have to start explaining what is a switch by now. The data layer has to do with the switch, because it is from the switch we connect our cable from one laptop to another. Is being donated by the switch, and the information moves that way. Now, on the network layer, by today's class, we'll be introducing a router. Other classes will be working with the switch. Today's class will tell you a very important function of this router. Please, these classes are important because this is the backbone of cybersecurity, that is networking. The router has to do with the network layer because it is the router that interprets and translates your information. Remember, I told us that our mobile phone, once we create hotspot, it becomes a mini router. I said that because the mobile phone acts as an interchange with your network service provider, which is your SIM card, MTN. So that means at that point of you creating an hotspot, your mobile phone now becomes a router because it is allowing other people to access your network. We are going to demonstrate it very soon. And it goes through the transport, through the software that has been developed till it gets to the last layer. This is another flow of that again. Your physical layer transmits the data. Did we talk about MAC address? Did you learn about MAC address? So if you learned about MAC address, you may have learned that every data that transmits information has a MAC address. Hope you are told. MAC address is specific to every hardware. Every hardware transmitting information has a MAC address by default, while IP address is assigned to you by the router. MAC address comes with you. IP address is given to you by any network you wish to join. So because of that, we can comfortably tell you that on the data layer, which is your switch, once you plug your switch to your laptop, an exchange of MAC address occurs. Because at that point, at the point of plugging this from my laptop to the switch, I have not yet added a router. Since I have not added a router, IP address cannot be given to me by anybody. We are going to see that later on. And since it can be given to me, what am I now having in common with my neighbor? MAC address. We talked about plugging this cable from one laptop to another. At that point, IP address is not exchanged. So what are you using to communicate among yourselves? MAC address. When you put on your Bluetooth and someone else connects to your Bluetooth, it is the MAC address of that Bluetooth that is exchanged and used as a medium of communication at that point. Because there is possibly no IP address that have been assigned. So the information flows, and when a connection is established and terminated at layer 5. I told you layer 5 is the section layer. So that is where information connection is established and terminated. Still on the OSI layer, we have the upper and the lower layers. The other parts you may need to read up. I want to skip that entire area. The other slide are telling you about the different meaning of layer 1, 2, 3, 4, 5, 6, 7. You can read up all of that. Layer 3 is very, very important because layer 3 is the fulcrum of all what we are doing. Layer 3 has to do with network. And when we talk about network, layer 3 is when our router comes into being. This is a router, as small as it is. This is a router. This is also a router. The size is not the issue. What matters is the function. So a router is actually where all these activities takes place. In the router, network address is given. In the router, communication takes place. In the router, there is a flow of information. In networking, we call those information packets. In networking, we call information packets. When your laptop is connected to my laptop and I send a WhatsApp message or an email to you, what is being flowed is packets. Packets are being transferred and being flowed. Inside those packets, they now have instructions. Every packet has its own instructions. Packets can be filtered. This is where we have our firewall. Now let's assume my laptop is connected to all of you. During the exams period, my laptop was the server and all your systems and phones were the clients. What was being exchanged were packets. Those packets were coming with particular assignments. So when you connected to me, the software that was developed has already determined what each packet should be. So my examination software have told your laptop that when you put in a particular username and password, your username and password by the software developers, that username and password is giving you access to only student level. Student level means that you should only see the questions and tick the correct answer. Am I right? That means packets were being filtered. One of your laptops, like my colleague's laptop, was a server. It was also connected to my laptop on that same network. But the packet it was pushing out and receiving from me, the software developer have said that with the username he used to log in, his own packet should be able to sign into an administrator account, but on the same network. That means a process called packet filtering was being performed in the router. The router was, if you guys notice very well, you would have noticed there was one small device that was somewhere here. Did anybody notice that? Let me bring it. There was one small device that was there. Okay, this is it. This is also a router. This was the router. So we had, in that our exams, we demonstrated all what we were learning. We had a router, we had an access point. Did you see the access point? The white one. The access point, we used it because we were doing an hybrid connectivity for that exam purpose. We did an hybrid connectivity live during the exams. My laptop connected to the access point through Wi-Fi and also through LAN because my laptop connected here. Now the access point also connected to this device. That means this device was doing both the work of a switch and a router at the same time. So we did an hybrid connectivity because all of you could not connect through cable to this device. You had to connect wirelessly. So this was doing the work of packet filtering. So packet filtering was also done by this router because if internet was on that network, through packet filtering, the network will tell you this person is trying to watch YouTube. Meanwhile, in class, we are not meant to allow students to watch YouTube, but staff can watch YouTube. That is what is called packet filtering. And this router also allows you to make, this router makes the decision of the best path determination. Let me explain that. Now, we are trying to send a message to someone in Lagos. Or let's just say I'm trying to send a message to that class. And I have 3 access points connected to this router, not just one anymore. Each of those access, maybe one is here and one is here. It is this router that will tell your phone, please send that information through the access point here because the person is trying to connect is in the other wing and the Wi-Fi strength of this one is stronger than the other one. So when your phone is to connect him to that one because it is closer to the person he's trying to send information to. The router makes that information. That is what we call best path determination. Layer 3 is very, very important and critical. Layer 3 handles all what I have told you. It handles the decision. It handles what is called network congestion. We will explain that later on. I've already explained layer 2, so I won't go to that. I've already explained layer 1. I will skip this. You may decide to read this, but it will not come out in your exam. We put it just for those that may want to dig deeper into network engineering. Data encapsulation is just how data is being hidden, transmitted. That is what we call the data header, IP header, and so on and so forth. We are not going to dwell on this right now. We have already talked on all of this. There's what we call data flow. I've already explained the data flow simply refers to the movement of data within a network from one interface to another. Now, we come to what we call the TCP and IP model. We are done with the OSI model. We now come to what is called the TCP/the IP model. The OSI model is recognized, and we have to call the TCP because TCP model is strictly concerned with communication of data. TCP model is strictly concerned with transmission of data. And we just have about 4 layers. The network layer, the internet layer, host-to-host layer, and the process communication. We have what we call the Department of Defense, that is US. They simply broke down the OSI model into 4. They lumped the data layer and the physical layer and called it network. The network layer, they called it internet. Let me give you the reason. The primary function of a router is to send everybody connected to it to the internet. or the intranet. A router does what is called a kind of a conversion or translation, just like the aeroplane. The aeroplane takes locals like us from Nigeria to another international country, which is Ghana, which is done by the aeroplane. So that is the job of a router. Encapsulation or conversion. Conversion processes occur in a router. So in the TCP layer, we have what is called the TCP model. We have the application layer that contains protocols that implement functions such as delivering of email, browsing of websites, logging in, and so on and so forth. Internet is simply delivery of data from one process to another. Please, I'll still skip this and go on to what is called port numbers. I will only introduce this. As we proceed, I'll be explaining. Please, let's just follow. For now, this is just theory. The ones you need to understand, I'll tell you. In networking, we have what is called port numbers. I will explain it as we proceed. You know, these guys, they are the ones that try to confuse us. So they sat down and possibly had a meeting somewhere and just decided to create some numbers for different activities we are carrying out on the internet. They are the ones that created it and pass it over to us. So our job is just to understand it and apply it when needed. Now, when we call FTP, FTP simply means File Transfer Protocol. FTP in the other way around means Zender. Hope you use Zender. Zender means transferring a file from your phone to another phone. So those guys on the internet are simply saying that whenever a file is to be transferred from one process to another, the system should use the number called number 21. We should use a number called 21. Please don't ask me why they selected 21. You wanted to ask, or you wanted to tell us which of them to ask. You can Google it. Why was 21 selected? But for this class, we just know that for file transfer services, we use the port number 21. How do we apply it? When we log into this router, we are going to show you how to do all of that. We have what is called SSH for those that do hacking. If you want to force yourself into an application, you must make use of number 22 and number 23. For emailing, all the emails usually send, Gmail, all other mails, they make use of number 25. Then we have 53 for domain. Then all the browsing you browse on the internet, www.whatever, any website you are visiting, that www.whatever, by default, they make use of number 80. I made a statement, I said by default, so that when I bring in another number for web browsing, I'll remind you of this statement. By default, they make use of number 80. The rest of them, we don't really need them. We'll need them much later. When we learn of IMAC, SNMP, and so on and so forth, we'll need them much more later. Now, for secure browsing, we have unsecure browsing and secure browsing. For browsing securely on the internet, we use the number 443. For the level of this class, we will simply ask you, we may ask you, FTP, what port number is associated with file transfer? We may not ask that question directly. We may simply tell you, in a class, maybe a file is meant to be sent from cybersecurity to information technology, and students have developed a whatever. After telling you a story, the next question would be, tick the port number that was used for such protocol. What you should know is that just look at for what matters. In all of those stories, what matters is a transfer has taken place. So you have to select number 21 as the port number. We have another protocol called UDP. We'll explain it in 300 level in detail, UDP. For now, UDP simply means User Datagram Protocol. It is also a protocol for file transfer, but there is a difference between UDP and TCP. TCP has to do with secure connections. Please, for this class, this table is what you need. TCP has to do with secure connections. UDP has to do with unsecure connections. TCP connections are usually fast. TCP connections are slow. UDP connections are fast. TCP connections, you guarantee that if I send a WhatsApp message to courseware telling her inform the whole class that we have test tomorrow, we are guaranteed that she will deliver that information. But for UDP, there is no guarantee that she deliver that information, so we may have to sack her from being a course rep. That's what UDP does. But for TCP, we are guaranteed that that information will be delivered. TCP is used by critical applications. For cybersecurity kind of applications, we use, in fact, critical bank-oriented applications, we use TCP. UDP is used for real-time applications, chatting applications, applications like e-voting. You are voting, you are meant to see the result. UDP uses such applications. TCP does not check for error. Sorry, TCP checks for error. UDP basically checks for little error. In TCP, you must give me an acknowledgement that my request has been received. So assuming we want to speak in cybersecurity terms, I could tell course rep, inform your class that there is a presentation tomorrow. Students may prepare to present. I will then tell her UDP. I will then tell her, inform your class that they are to submit an assignment which will be graded. I will then tell her TCP. What should she understand by those two informations? TCP means confirm and tell me that you have informed them. UDP means I don't need any confirmation because it is not really compulsory. And I'll be chatting with you that way now. So if I tell you TCP or UDP, you should know the kind of reply to give to me. Or if you tell your colleagues, a class is holding tomorrow, UDP. UDP may mean maybe there's no test, or there's no CA, or there's no grading on attendance. If she tells you a class is holding by 9 o'clock tomorrow, TCP, she don't have to explain. So we should be using cybersecurity slangs on your groups. So let's continue. Yeah. It's 12 o'clock. So automatically you'll be our timekeeper. So 12 o'clock, okay, we are on break, right? Okay, so we'll be going in 5 minutes. 5 minutes. 5 minutes time. Let's just see something. 5 minutes time. I just want to confirm that. Okay. Please, this table, very important. Please, when you get this slide, this table is very, very important. The difference between OSI model and the TCP model. So when we come next, we are going to look at, did we do DHCP and static in the previous class? Okay, so when we come next, we are going to start from here and go straight to our practical. Please, let's come by 1. We are starting by exactly 1 p.m. because we have practicals, please. Thank you very much.